We're looking at computer and statistics, GST 121. Now, what's computation? As I was trying to say, computation has different definitions. They did not actually come out to say, okay, this is computation or that is computation. Why? Because of the discovery of new things every day regarding the computation, the definition of computation. So that is why they did not actually come out to say. But for now, let's take computation. If we are defining computation or computation is being defined, computation is always defined relative to computational models that specifies the agent performing the computation. Computation is seen as a process generated by that agent. Now, computation is any type of calculation that includes both arithmetic and non-arithmetic steps and follows a well-defined model, for example, an algorithm. Now I come over it again. Computation, in this course, we'll be looking at computation as any type of calculation that includes both arithmetic and non-arithmetical steps and follows a well-defined model. For an example of that is the algorithm. The algorithm is an example of that. Now, we talk about the theory of computation. The theory of computation can be divided into three areas. One, automata theory. Two, complexity theory. Three, computability theory. These are the theories of computation. Now, this brings us to, in computation, there is something we call branching in computation. Now, before I go further, as a matter of recap, trying to talk what we are supposed to talk next before we go into the topic we have for today. Now, we look at branching. Branching is a basic concept in computer science. Branching is an instruction that tells a computer to begin executing a different part of a program rather than executing statements one by one. Branching is implemented as a series of control flow system in high-level programming language. Now, let's take this for example. Computers are supposed to follow, when you write a code, the computers are supposed to follow the codes step by step. But there are sometimes you don't want the computer to take to follow a particular step or to jump a particular step or to not to not to impute or to not to work on a particular step. So you have to, like, okay, write a program that will enable the computer to deviate or to stop where it is and jump to the other. That is branching. To the, like as I said, branching is an instruction that tells a computer to begin executing from a different part of the program when you have two parts of the program to go with. Branching has Branching includes if statements. Now, when implementing branching, you use if statement. Now, for example, you tell the computer, like some of us in algorithm, 1 plus 1 is 2. If it is not, go back. Do you understand? Go and recompute it. Now, what are you saying? If you add 1 plus 1 together and you don't get the answer to, you are telling the program go back to do the same thing, or go, and if it is true, quit the program. So that is the if statement. That is the if statement. If 1 plus 1 is 2, quit the program. But if it is not true, then go back and um recompute the program. Then for loops, we also have for loops. Now, for loops is you tell the computer for this in this place and this is that place, then do this. So you tell the computer when this is this, then carry on with this, and when the A is not equals to B, then this is what you do. So now we have another one, while loops, and we have go to statements. So these are the series control flow system in high level languages that we use in branching. These are the systems we use in branching. Now they include if statements, for loops, while loops, and go to statements. Branching instructions are imputed at the CPU level through they are much less sophisticated than kind of instruction found in high level languages. Types of branching or types of program instruction in branching. Now we have the linear program and branching program. A linear program is a straight line program, and as a learner starts from his initial behavior to the terminal behavior following a straight line. Is a straight line. A linear program is a straight line program as the name implies. Is a straight line program as the name implies. Characteristics of linear program. Now, one of the characteristics of linear programs are is exposed to small amount of information, proceed from one frame to one item of information to the next in orderly function. Linears are exposed to small amount of information and proceed from one frame to one items of information to the next in the orderly fashion. Linear response overtly that their correct responses can be rewarded and their incorrect and hence incorrect responses can be corrected. Now, number three is linears are informed immediately about whether or not their responses is correct. That is, linears can get feedback. Linears proceed at their own pace. They are self-paced. They go on their own pace. They go on their own pace. So that is the features, the characteristics of linear program. Now the features of linear program. Linear means proceeding. Let's go further and look at fundamentals of linear programming. Yes, the fundamentals of linear programming. One, principle of small steps. Linear programming is based on five fundamental principles. Please take note of it. Number one, principles of small step. Two, principle of active responding. Three, principle of immediate confirmation. Four, principle of self-pacing. Five, principle of testing. I said linear programs I said linear programs are based on five fundamental principles, and number one of it is principles of small step. Number two, principle of active responding. Number three, principles of immediate confirmation. Number four, principles of self-pacing, and number five, principles of student testing. So those are the five fundamental principles of linear programming. Those are the five. Now, there are four. When we talk of linear programming, there are four frames in linear programming. There are four frames in linear programming. We talk about the introductory frames, two, the teaching frame, three, the practice frame, and four, the testing frame. So these were all we were supposed to look into last week that we couldn't as a result of technical effort or technical issues which were not able to resolve and which we are still trying to resolve. That is why you cannot see my screen right now. But if you can't hear me audibly because of the video, you can go into the audio mode and you'll be able to hear me safely. Now, there are limitations when it comes to linear programming, but for sake of time, I will advise us to read about those linear programming and to see what we can do in when it comes to linear programming. Now, this is we've talked about branching, so and is a break function of a thing. Now, another thing, okay, let's quickly take example. Okay, you guys cannot see my screen. Let's look at iteration. Iteration. Let's look at iteration. Now, iteration is based on theory of operant conditioning. Oh, sorry, that is iteration. Let's quickly look at iteration. And before then, let me tell us about if you can see my screen on this. If you can see view the screen, we have the different types of frames in which you can work on in our frame. And I said let's read about linear programming and let also look about the limitations of linear programming, try to know the limitations of linear programming. So let me quickly talk on iteration before we move on to what I have for us for today. Iteration in the context of computer is the repetition of a process in a computer program, usually done with the help of loops. Iteration is a repetition of process in a computer program, usually done with the help of loops. Iteration is a process of repeating steps. Okay, for example, you take your food, you get your food, put your food on the dining, you hold your spoon, your tablespoon to eat. Now you take from the food, you put it into your mouth. By the time you finish with that, you go back again, you repeat the steps until you are done eating the food. That is iteration. So you continue the process. It's a process of repeating steps. Eating, for some of us that eat swallow, you take a wrap, put it in your mouth, then by the time you swallow it, you go back again, you take the swallow, put it inside the soup, put it in your mouth. You are repeating the process until you are satisfied or full, or until there is no more on the plate. So iteration is the process of repeating steps in programming, repeating steps. Now you must have seen some games, or you must have played some games, and as if the you playing the game, it wants to it wants to get to an end, it continues again. Those are iterations. So repeating the steps over, you are just going through a loop. You're just going through a loop. You're just going through a loop. Now, if iteration has different uses loops, and we have different types of loops. We have for loops, we have while loops, and so for loops involve initializing the variables, defining the loop condition, and implementing the incremental or decremental statement. For loop is initializing the variables, define the loop conditions, and implementing the increment or decrement statements. Now, if you could view my screen, I have an example of for loops there. I have an example of for loops. For loops, when you talk about for loops, initialization, condition, increment or decrement of the program. Then we have the while loop. A while loop repeatedly executes a target statement as long as a given condition is true. A while loop continues to execute a statement as long as a given condition is true. Now let's take for example. Now, if you are eating, and as long as the food is still in your dish, and you are taking the process, take from it, take it through your mouth, you are continuing it in a loop, going like as long as the food still remains in that plate, you are repeating the process over and over again until when the food is finished from that plate, or when you exhaust the food from the dish you are eating it with. Now what happens? The process stops. So that is like a while loop condition for us. That is like a while loop condition for us. So I want us to study iteration, branching, linear programming, and so that we will be able to do some things. Now, application of iteration. One is problem solving in arrays. Problem solving in arrays. Problem solving in arrays, vector, list, strings, etc. Two, problem solving using stack, queue, and priority queue. Three, bottom-up implementation of dynamic programming. Bottom-up implementation of dynamic programming. Four, implementation of greedy algorithm. Five, problem solving using hash table and BST. And six, iterative implementation of recursive code using stack. So for the sake of for this course, and I want to like issue our assignment for today before we go into the next course. Then the assignment number one is write 10 programs using branching iteration in each of the following programming language. One, Java programming. Two, Python programming. Three, C programming. Four, C++ programming. And five, algorithm. Number two, what is algorithm? What is algorithm? 2A, explain the different parts of algorithm. Explain the different parts of algorithm. So, number three, state the procedure for finding square root of a number using guess and check. So please, and the assignment should be submitted to safetybliss@yahoo.com. I spell SAFETYBLISS at yahoo.com, and it must be submitted not later than Wednesday, 29th April 2020, and the deadline time is 23:59:59. So let's look into what we have today, and that brings us to sampling theory. Sampling theory. So that is what, with the little time we have, let's quickly look at sampling theory. We were able to like recap what we should have done yesterday, but today let's start with sampling theory. Now, what is a sample? A sample is a portion of population which is examined with a view to estimating the characteristics of the population. A sample is a portion of population which is examined with a view to estimating the characteristics of the population. Now, what are we just trying to say with this? Now, a sample is when you have different sample, you have different products, and you want to find out, oh, you want to carry out some kind of surveys. You pick random, you pick some samples, you pick from the products you have. Okay, let me take from this and make my survey and come out with a real solution or a decision. Now, for example, we have different type of noodles in the market. For people that knows me very well, you know I will always make an example with this. We have different types of noodles in the market. We have the Indomie, we have the Chiki Chiki, the Nunu, to mention but a few. And you can just decide to say, okay, I have different types. So which one will I invest in? Which one will I go for? So you can decide to like, okay, let me take a sample from them and see the one that is best. So you can take a sample, and from there, when you carry out your research or your test, you'll be able to come out, oh, this is the best that I should invest in, or I should concentrate in eating. So sometimes in start taking a population samples from population, you want to take census and you decide like, oh, I cannot to take census of the whole area, it will cost money, so let's just take samples from different places. You want to look in a class, for example, you have so many students and you just want to know the average height or the average age of the people in the class. You pick samples, and with the samples you'll be able to come out with a decision that, oh, these are the findings I was able to find in this class. There are two ways of collecting statistical data, and one of them is complete enumeration or census. The second one is sample survey. I said two ways of collection of statistical data. One is complete enumeration, in other words, census, taking census, or two, sample survey. You can use sample survey. This brings us to some concept of sampling. The concept of sampling, one, is a process of selecting units from a population. Sampling is the process of collecting units from a population, collecting a small amount, a small part of a population, and using it to predict what you are looking for or what you intend to achieve. Number two, it's a process of selecting a sample to determine certain characteristics of a population. Is a process of selecting a sample to determine certain characteristics of a population. And number three is a subset of larger population of object individuals, household, businesses, organizations, and so forth. Now, sampling, um, why sampling? Why do we go into sampling? Why sampling? Somebody might ask, what is sampling? Why sampling? Why is this so important? Now, one, to get information about a larger population, now we need sampling. Why? Because it's less cost. Now, let's take for example, in the federal government want to take census of in Nigeria, of the citizens in Nigeria. You know the billions it will cost the federal government. So by using sampling method, it reduces the cost. So that is why we say less cost. Two, less field time. It's less people. It reduces the less field time, the less people going out field to count from house to house. So it reduces less field time. So sampling is because it reduces less field time, is less cost, less field time, to more accurate, can do a better job of data collection. More accurate, it can do a better job of data collection. Now, for where it's impossible to study the whole population, sampling can be used where it is impossible to study the whole population. Sampling can be used in that area. Now, let me look about the classification of sampling techniques. Sampling techniques, the classification, we have non-probability sampling techniques and we also have probability sampling techniques. Now, in non-probability sampling techniques, we've looked at the convenience sampling, the judgment samples, and the quota sampling, and snowball sampling. So in non-probability sampling, we have the convenience sampling or the convenience samples, whichever you want to say, the judgment sampling or judgment samples, the quota sampling or quota samples, and snowball sampling. And for the probability sampling techniques, we have simple random sampling. And number two, we have systematic sampling. Number three, we have stratified sampling. And number four, we have cluster sampling. Now, probability sampling utilizes some forms of random selection. Probability sampling uses or utilizes some forms of random selection. A probability sample is a sample in which every element of the population has a known and equal probability of being selected in the sample. A probability sample is a sample in which every element of the population has a known and equal probability of being selected into the sample. Now let's take for example, we are all Nigerians, and the federal government said, okay, I want to give some Nigerians 5,000 naira, just the way the government has said we are giving 5,000 naira to all Nigerians, to some selected Nigerians. So you and I has the chances of being selected if it is done appropriately. You and I, every Nigerian has the probability of being selected. You have equal right, equal probability of being selected. Why? Because you are a Nigerian and you are in Nigerian. So you might just be surprised your name will be there. Oh, or you just received the alert on your bank account. The federal government has credited your, yes, it's because you have equal right, or rather you have the probability of being selected for that award, for that pay by the federal government. Now, the non-probability sampling, this does not involve random selection. The non-probability sampling does not involve random selection. Now, if you go through it, if you are asked what are the differences between probability sampling and non-probability sampling, so you should be able to tell us that the probability sampling involves random selection of a part of our population, and the non-probability sampling does not involve any form of random selection. Probability samplings are of the following types. Types of probability sampling. Please, let's pay attention to the list, the types of probability sampling. One is simple random. Simple random. Number two is random. Stratified random. Number three is systematic random. And number four is cluster or area random. And number five is multi-stage random. Now I go over it. I said probability sampling, types of probability sampling. One, simple random. Two, stratified random. Three, systematic random. Four, cluster, or which you can also call area random. And five, multi-stage random. Now, for the non-probability sampling, The types are: one, convenience sampling, convenience sampling; two, judgment sampling; three, quota sampling; four, snowball sampling. So for the non-probability sampling, the types we have, types of sampling for non-probability, we have the convenience sampling, judgment sampling, quota sampling, snowball sampling. So now for simple random sampling, probability is selected using n over lowercase n over capital N or uppercase N. That is when population is rather uniform, e.g., school, colleges, and students, low cost houses, simplest, fastest, cheapest, could be unreliable. So we use these simple terms, the N all over capital N. So these are what we can use. Random selection, pick any element, use any table. So random selection picks any element, use any table. For stratified random sampling, it breaks population into meaningful strata and take random samples from each stratum. Now it breaks population into steps. Let me use the word into meaningful step and take random sample from each step. Now, for example, let's come over again that the federal government is going to give every Nigerian some set of Nigerians money, and we have to break it into steps. How do they select? Now they can decide to say, okay, let's give them, and the whole people they will give the money will be just in Lagos or in Abuja or in Kano or in Borno, but everybody is not satisfied. It didn't cover the whole state. So it can be broken into steps, and from each step, then little samples are taken from each step so that the money will go around the 36 states in Nigeria. So that is stratified sampling. It breaks down population into meaningful strata or into meaningful steps. Let me use my word meaningful steps and take random samples of each step because they are very, very important. It can be proportionate or disproportionate within a strata or within a step. When population is not very uniform, it can be proportionate or disproportionate within a strata. That's when the population is not very uniform. When the population is not very uniform. Then another one we're looking at is the systematic sampling. Systematic sampling. Now, systematic sampling is simple or straightforward in nature, or stratified in nature, sorry, simple or stratified in nature, Systematic is the picking up of elements, e.g., fifth visitors every 10th house every 15 minutes, etc. Now it is the picking up of elements. Now every step you just want to like, oh, after this person goes out every 15 minutes, now you keep taking picking up elements or taking note of it, or this person, this is what this person do, or at every year rain falls more in this month than in other months. Why? You being able to look at it, and from there you can tell that, oh, the rain will fall more in this month. Why? Because you studied it from the past years that, oh, at every month, at this so and so month, we always have larger amount or high amount of rainfall at so and so month. So you could be able to use it to give a decision and say, okay, by this month next year, this will still have the larger amount of rainfall. Now, the steps we use in systematic samplings are: one, number of population, two, decide on the sample size, that is small n, decide on the sample size, then three, decide on the interval size. Now, the formula you can use for that is K is equal to capital N all over lowercase n, and four, that is lowercase n, that is the number of population, capital N is the number of population, and sample size, which is small n is a sample size. Then number four, select an integer between 1 and k, and lastly take the case for every kth unit, take the case for every kth unit. Now, let's look about some clustering samples. Hope I'm not too fast. I know we have little time. Um, let's look at clustering sample. Clustering sample research involves spatial issues. Sampling involves analysis of geographical units. Clustering samples, some samplings involving analysis of geographical units, sampling involving extensive traveling, trying to minimize logistics and resources. Now, the steps we use in clustering sampling are: one, divide population into clusters, localities, that is into clusters or localities. You divide the population into clusters and into segments, whichever language you want to use there. Number two, choose clusters randomly. Choose clusters randomly, that is simple random, stratified, choose them randomly. And three, take all cases from each cluster. Take all cases from each cluster. Take all cases from each cluster. Now, the non-probability sampling methods. Non-probability sampling methods, we have the convenience samples. Non-probability samples used primarily because they are easy to collect. The non-probability samples are used primarily because they are easy to collect. Two, judgment samples. Judgment samples. Now, the judgment samples in non-probability samples, in which the selection criteria are based on personal judgment, that the element is representation, is a representative of the population under study. The judgment samples is in non-probability sample is a selection criteria are based on personal judgment that the element is a representative of the population under study. Then the quota sampling. The quota sampling is a sample in which population subgroups are classified on the basis of researcher judgment. Quota sampling is a sample in which population subgroups are classified as the basis of researcher judgment. And the snowball samples. The snowball samples in non-probability sample is a selection of additional respondents based on referral from the initial respondent. Is a selection of respondents based on referral from the initial respondent. So this is what we have on sampling theory. This is how far we can go on sampling theory. On your own, I want you to, that sampling theory is wide, and when we have much time, we're going to do some calculations on sampling theories. But I would advise you to, on your own, read about sampling theory, then get the calculations, study the calculations, try to know much about it. And for the sake of time, I want to read to us again the assignment. Please take your pen and listen carefully. Assignment number one: write 10 programming programs. Write 10 programs using branching iteration in each of the following programming language. 1. Java programming. 2. Python programming. 3. C programming. 4. C++ programming. And 5. Algorithm. 2. What is algorithm? 2. What is algorithm? Explain the different parts of algorithm. 2b. Explain the different parts of algorithm. Explain the different parts of algorithm. Explain the different parts of algorithm. 3. State the procedures for finding square roots of a number using guess and check. State the conditions for finding square root of a number using guess and check. State the condition for finding a square root of a number using guess and check. Number 4. What is bisection method? What is bisection method? What is bisection method? What is bisection method? B. Give examples of problems solved using bisection method. Give examples of problems solved using bisection method. Give examples of problems solved using bisection method. Now, the email to send it to is safetybliss@yahoo.com. That is SAFETYBLISS at yahoo.com. The deadline for the submission of this assignment is Wednesday, 29th, 23:59 p.m. Wednesday, 29th April 2020, time 23:59 p.m. Please, let's make sure our assignment gets to this email on or before that time. So from what we've been able to look at, let me just try and make a recap of sampling theory. And we said that samples, I was able to let us know that sample is a portion of population which is examined with a view to estimating characteristics of population. And I said there are two ways of collection of statistical data. One, complete enumeration. Two, sample survey. Sample survey. And we also look at them. I also made us talk about the I also talked about the concept of sampling, and I said is a process of selecting units from a population. Now, I tried to establish, in fact, make an example of federal government trying to like give everybody some set of people in Nigeria a particular amount, or they said 5,000, and it's not everybody, so they have to take sample. It's a process of selecting a unit from a population. It's also a process of selecting a sample to determine certain characteristics of population. Is also the subset of a larger population of object individuals, household, businesses, organization, etc. So we've been able to look at that, and I also made us to understand the reason why sampling. I said it less cost, two, less field time, three, more accuracy. That is, can do a better job of data collection. Four, when it is impossible to study the whole population, then we use sampling. So I want to thank you all for listening to me today, and I want to like, till we meet again next time, I want to say stay safe and meet you same time, same station, or same channel, or same site next week. Do have a lovely day. I am Engineer Nathaniel. Thank you, and God bless you.